Hello guys, welcome back to the quantity surveying workshop and to another video. In today's video we're going to be going into the measurement of the staircase, a dog-leg staircase. We're going to be going into it proper, and in today's video we're going to be treating the measurements for the concrete work and for the form work. So the specification for this staircase includes the following: 333 mm thread with 12 mm thick marble tile finish, 175 mm riser with 12 mm marble tile finish, 75 mm thick narrow post, 150 mm thick waist, 200 mm thick landing, 50 mm thick handrail, 22 mm thick balusters, and mild steel plates welded to all balusters and narrow posts. So first we are going to be calculating for the concrete works, and this is the plan we are going to be using. So to read this drawing, you can see that we have two flights, the first flight and the second flight. And the first flight consists of how many steps? 1 2 3 4 5 6 7 8 9 steps, similar towards the second flight, while there is a landing here. So as you can see, this is the section of the staircase. The width of the staircase of the landing is 1200. So the staircase has a base. And you can see the starter bars. The height from the beginning of your oversized concrete down to beneath your landing is 1575. So as you can see, the thickness of our landing is 200 mm as stated in our specification. So the next flight from the top of our landing down to the base of our suspended floor is still 1575. Now in a case where you are not given all this is how you find for all this height. You know that they're giving you your riser as 175 mm in this case. That's this in your specification. So now all you need to do now to find for the heights from the oversized concrete down to the base of your landing, all you need to do is this: find the number of risers you have from the beginning of the oversized concrete down to the surface of your landing. So we've counted 9 steps, so it means that we're going to be having 9 threads and 9 risers. So our risers now will be 1 2 3 4 5 6 7 8 9. So if we times 9 by the dimension of our risers, which is 175, it will give you 1575. That is how we got our 1575, and similarly to the second flight. Now the first thing we're going to be calculating for is our concrete works. If you watch the introductory video, you would remember that I said we are expected to calculate for your concrete works. You have to divide the staircase into different parts. So if you haven't watched that video, please do so to watch the video, because I stated important points that would help in the measurement of a dog-leg staircase. So this is what we have here. You know that this is our landing. So the first thing we're going to be doing now is to calculate for the steps. So you see, this structure like this is not this structure is not a regular shape. So we're going to be cutting this structure into regular shapes. So now the first thing I'm going to do now is to cut out the landing. So now if you look at this, if I use this my ruler to cover this part, you can see now that this landing here is a rectangle. So if this part is my landing, I can cut this part like this for the steps. So minus this first part on top, you know that we've cut it to be part of our landing. So now the steps, now we've cut it now to become what? A triangle. So now this triangle 1, triangle 2, triangle 3, triangle 4, triangle 5, triangle 6, triangle 7, triangle 8, and what? Triangle 9. The same number of our what? Steps. So the next thing I'm going to be cutting now is what? The waist. So if I isolate the step now and I isolate the landing, we are going to be having this parallelogram here as our what? Waist. So after isolating the waist, we are going to be having what? The base of what? The staircase. And this is what I mean. So as you can see, this is a caricature explanation of what I just did right now. So as you can see, we've isolated the steps, forming what? Triangles. We've isolated the landing, forming what? A rectangle. We've isolated the waist, forming a what? Parallelogram, and same as the what? Base. So now this is the idea I go about measuring for my what? Staircase, the concrete works for my staircase. So now, since we know the area of a rectangle and other shapes we've cut this irregular shape into, we can now see, for example, this is a rectangle. We know that the formula for the area of a rectangle is what? Length times breadth. So we can now add another parameter, which is the thickness, h, which will give us what? The volume. And you know that concrete is measured in what? Meter cube, which is what? Volume. The same as what? The steps. You know that the formula for calculating the area of a triangle is what? Half base times what? Height. So now we'll now add another parameter, which is what? The thickness, and that will give us what? The volume for the steps, for one step. So you will multiply it by the number of steps you have in your drawing, which in this case we calculated as what? 9 steps. Then you now do your waist. You know that this waist here, we've cut it into a parallelogram, and the area for a parallelogram is what? Base times what? Height. So we know that the base would be the thickness of the parallelogram, and the height would be the height from the base of our oversized concrete, as this part of our oversized concrete, down to the base of our landing. That will be the height of the parallelogram. And then we can now calculate for our base as either a square or a rectangle, depending on what? The nature of the dimension. So let's go right into the calculation. So first things first, when, like I said, we've divided this staircase, this complex shape, into different shapes. So now first things first, let's start with our what? Step. So now this is the area of a triangle, right? So we know that the area of a triangle is half base times height. So now we are going to be relating this formula to what we have in the part of this staircase. So now the base, let me just write it here, triangle is equal to what? Base times height all over what? 2. So now if you look at this diagram, we can assume that this triangle is upside down. It's upside down. So this is our base. So the base would be the what? Tread, and then the height would be the what? Riser. Let me come again. The area of the triangle is base times height all over 2. So which part of the step is the base? It will be the tread. Which part of the stairs will be the height? It will be the what? Riser, because it is the riser that gives height to the what? Staircase. So from here to here was given as what? 175 mm, while from here to here, which is our tread, was given as what? 333 mm. Which means this formula now, if we want to impute it, it will be what? 333 times what? 175 all over what? 2. So whatever we get will be the area for 1. If we now multiply, for example, if what we had in our area was what? Let's say 600, we can now multiply it by another parameter, which is the thickness or the width of this staircase, which in this case, here is given as what? 1200. So if from here to here is 1200, it means that if we multiply that parameter with this, it means it will give you your what? Volume. So now that is that for the step, and we are still going, that is the same approach we are going to be using for others. Let me take another example, the landing. So the area of our landing is what? Length times breadth. Landing is equal to what? Length times what? Breadth. So now if here, from here, don't forget our if here, so now if here down to here is our landing, the length of our landing, and that parameter in our plan, or in our section rather, is giving us 1200. So it means that that part will be what? 1200. Then we can now use the thickness, which is from here to here, which is giving us what? 200. From here to here is what? 200. So if we now have our length and our breadth, you can now say 1200 by what? 200. Whatever we have here is our area. So we can now multiply it by what? Another parameter. And the last parameter would be what? This part of the staircase from here down to here, which is 2500. But mind you, sometimes people chisel into the wall. People construct the landing a little bit into the wall to give it additional support. So if you are doing that, you can also add for that. You can also add for that operation. If not, you leave it like that. So you multiply it by, in this case, 2500. So whatever you get here will be the volume of your landing. Likewise, you do the same thing for the waist. You do the same thing for the base. So let's go now into the standard of what? Measuring practice. So now we can now start with this. So what I did here was that I tried to calculate for the unknowns. The unknowns as the angle, the slope of the staircase, as well as what? The string of the staircase. So if you look at the section of the drawing, the section drawing, you will see that the slope was not given, and what? The surface of the staircase was not given. And we're going to be needing this surface when we're calculating for our form work. So I just made sure I did all the necessary calculations before I start booking for all the quantities. So how do I find for x, which is the surface of the staircase? So this is what I did. If you notice, this is the hypotenuse of a triangle. So if I bring out this right angle triangle out, that is what I did here. So now that I have this triangle out, x, which is the surface, how did I find these two values? Now if you see, this value here is the height of what? The staircase, while this value is the distance between the starting of the string down to the top of the string. So now when you are not giving this, or if you are not giving this, this is how you calculate it. I've already told you how to calculate for the height of the what? Of the staircase using your what? Risers. Now I'm going to show you how to find for this distance using your what? Thread. So now if you look at this, we're looking for from here to here. So now what can you notice? You can notice that from our second thread, which is this one, they are all along this distance. So this thread, 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 and then we can assume that the distance from here to here is the distance for a thread. So if you multiply the number of threads within this distance by our dimension, it will give us what? The distance from here to here. So now we know that in our specification they've given us our thread should be what, 333. So if we have 1 2 3 4 5 6 7 8, and then we can assume from here to here we'll make it as what, 9. So if we assume that there are 9 threads, so 333 times 9 will give us what, 2,997, and that is how I got this value, 2,997. So moving forward now, how do we find our what, slope angle? This is easy. You use your trigonometric ratios. So we have our opposite, we have our adjacent, we are looking for our what, angle. So we can find for the tan inverse of whatever we have. So we know that tan is opposite of our adjacent. So 1,575 divided by what, 2,997, which is what I did here, would give us what, 0.526. So tan theta is equal to 0.526. If you find the tan inverse of 0.526, it will give you what, 27.7 degrees. Therefore our slope angle is equal to what, 27.7 degrees, meaning that the slope or the angle they used to construct that particular staircase is this 27.7 degrees, and it was not given in our what, drawing. So now that we have our slope angle, the next thing we're going to be calculating for is our what, x, which is what, the surface of the staircase or the string. So now we can use Pythagoras theorem. Since we have two parameters, we have the opposite and we have the adjacent, so we can now say x square is equal to what, opposite square, which is what, 1,575 square plus what, 2,997 square. X square is equal to what, this. So the square root of this will give me what, 3,300 and what, 85.65 millimeters. So this is the dimension of our what, string, that's x. So the first thing we're going to be calculating for the concrete works now, as stated here, would be the steps. Now to calculate for the steps, I've already broken everything down. So if you look at this, we said that our step is what, the area is what, base times height all over what, 2, and we stated that our base would be what, the thread, and our height would be what, the riser. So this is how you book for your what, step. So the first thing you are going to book now is what, your riser. Your riser is what, or let's just say your thread. Your thread is what, 333. So we can now write 0.33. That's when you convert it to what, meters. The next is your what, so this is your base. The next is your what, height. So your height is what, your riser, which is what, 175. So if you convert it to meter, that will give you what, 0.18. So the next thing you are going to be booking now is the next parameter, which is the thickness. But in this case, the thickness would be the width of the staircase, that's from here to here, which is what, 1,200. So if you convert that to meters, it will give us what, 1.20. So doing this, what about the over 2 that we had in the formula, which is this, base times height all over 2? What you just do now, once you've gotten these parameters, you multiply it by what, half, and then you close. Doing this, you've measured for what, 1 step. So how do we now measure for the 9 steps that we have? All you need to do now, since they are the same dimension, the dimension for the thread and the riser for all the steps are the same, so you just multiply it by the number of steps you have, which in this case is 9. So doing that, you've measured for what, the 9 steps here in your first flight. But now in our observation, the first step, the number of steps we have in our first flight is the same as the number of steps we have in our second flight. So So instead of booking the first flight separate and the second flight separate, you can just book it the same by multiplying it by what? 2. So this is what we have here. This measurement here is a measurement. This measurement here, that's 0.33, 0.18, 1.20 multiplied by this half, is a measurement for the volume of concrete for one step. Multiply this by 9 because there are 9 steps in one flight, but there are 2 flights in the drawing, and the number of steps in our first flight is the same as the number of steps in our second flight, so we can still multiply it by what? 2. I hope you get the logic. So doing this, you've booked for your what? Steps in your what? First flight and in your what? Second flight. So after doing this now, you can what? Describe. So you describe by saying reinforced in situ concrete to what? Sloping works. Less than or equal to what? 300 mm thick in what? Steps of dog leg staircase, and then you close. Now if you multiply everything here, 2 times 9 times half times 0.33 times 0.18 times 1.20, that will give me what? 0.64. So the volume of concrete for all the steps in the first flight and in the second flight is equal to what? This 0.64. So basically, in a pictorial or in a diagram, this is basically what we calculated as the step, as the volume of concrete for one step. So as you can see, this is your riser, this is your tread, and this is the width of the staircase. So once you measure your step like this. So this is the volume for one step, multiplied by what? Your number of steps, and then multiplied by the number of flights that you have that particular dimension of step in. So doing this, you measured for your what? Step. The next thing we're going to be measuring for is our what? Waist. So now to measure for our waist, like I said before, after we've cut out our step and our landing, the shape of our waist is a what? Parallelogram, and that's what you have here, a parallelogram, and the area of a parallelogram is what? Base times what? Height. The base would be the thickness of the waist, while the height would be the height of what? The staircase, which we have already looked for. Let me just put it as what? Y. So we book. So the first thing we're going to be booking for is what? The thickness of the waist, which is what? 150. Convert it to meters, and that will be what? 0.15. And the height of the waist is going to be what? We've calculated it as what? 1,575. So convert it to meters, that will give me what? 1.58. Then we add our last parameter, we multiply it by what? The thickness, or rather the width of the what? Staircase, which is from here to here. Because if these are our steps, the waist will be under, supporting the what? Steps. So we need this dimension 1200 here. So we can now convert that 1200 to meters. That's 1.20. So now that we have this is the volume of concrete in one flight, for this waste in one flight. But the volume of concrete we have here would be the same as the volume of concrete we have here for the waste, because we have the same number of steps in the first flight and the same number of steps in the second flight. And remember, the waste is what is carrying the word steps. So if there are 9 steps here and there are 9 steps here, it means that you're going to be having the same waste carrying the 9 steps here, and the same value of waste carrying the 9 steps in the second flight. So what I'm going to be doing now is I'm going to be multiplying this by what? 2. So when we multiply that by 2, we will now find for the value in the squaring what column. So 0.15 times 1.58 times 1.20 will give me what? 0.284. So when I multiply that by 2, that will give me what? 0.568, approximately 0.57. So doing that is the volume of concrete for the waste in the 2 flights. Then you now describe by saying what? Reinforced in situ concrete to the sloping works less than or equal to what? 300 mm thick in what? Step in waste this time of what? Dog-legged staircase. And then you close. So doing this, you've measured for your what? Waste. So this is a pictorial view of what the waste would look like, the volume of concrete you've calculated for the waste. So this is how it would look like. We said that the thickness, the base, which is the thickness of our waste, is what? 150, which is 0.15 in meters, and then the height of the waste, or the height of the parallelogram here, is what? 1575, which is what? 1.58, and then the width of the staircase, which is 1200, will be our last parameter, 1.20. So what we have here in the first flight will be the same thing as what we have in our second flight, carrying the steps. So we'll multiply it by what? 2. And what do we have? 0.57. So doing that, you've measured for your what? Waste. So next would be the what? Landing. So now we know that the landing is a cube. So if we need to find that volume, we're going to be having our area, length times breadth times another parameter, maybe the width or the thickness. So now this is what we're going to be doing. We are going to be finding the length and the width. So if you look at this plan here, this part, this rectangle here, is our landing, but the landing protrudes into the wall here. So since we have from here to here as 1200, the dimension is given in our section. From here to here is 1200. If from here to here is 1200 and the thickness of our wall is 225, we're going to be adding 225 to 1200 to give us the total length of our what? Landing. So we know that the length from here to here is 2500. So this landing, we're going to be assuming that the landing, this 2500, there's an additional 50 mm protruding into the wall here on both sides for just the landing. So it's as if the landing is entering into the wall like this. So if we have 50 here, 50 here, 50 times 2 will give me what? 100. So 100 plus 2,500 will give me what? 2,600. So it means that the distance, the total width of our landing is 2,600. So this is what we're going to be doing. So the length would be what? Let's say 1,200. Then we'll add what? Wall, which is this wall here. Thickness of this wall, which is 225. And that will give me what? 1,425. And the next one we're going to be doing for is our what? Width. So the width is what? 2,500. So I'm going to be adding what? Projection. That's 2 by what? 50. And that will give me what? 100. So the width will now be what? 2,600. So this is what we have for our length, and this is what we have for our what? Width. So now the next thing we're going to be doing now is we're going to be what? Booking. So we're going to be booking the length 1.43, that's this 1,425 converted to what? Meters, and then the width 2,600 converted to what? Meters, which is what? 2.60. So the next parameter now will be the thickness of the landing, and in this case they've given us that the thickness of our landing is what? 200. So our specification also says it, 200 mm thick landing. So we will now write 0.20 when you convert it to what? Meters. So doing that, you booked for your what? Landing, because there's only one landing. You're not multiplying it by anything because there's only one landing in the drawing. So now multiply these three parameters and see what will be the volume of concrete you are going to be needing for your what? Landing. 1.43 times 2.60 times 0.20. That will give me what? 0.74. So you describe detour horizontal works, because landing is not slanting or it's not sloping, less than or equal to what? 300 mm thick. In landing, and then you close. So doing that, you've booked for your what? Landing. The next thing you're going to be booking for now would be the base of your what? Staircase. So now if you look at this drawing, you will see that this part of the staircase is your what? Base. Now you have to have it in mind that this base is also within the oversized concrete. So you have to be very careful here, if not you over measure. If you book your oversized concrete, maybe when you are measuring for your foundation, your oversized concrete in the foundation, if you book for your oversight concrete everything here, including the oversight concrete, that's this part in the staircase, all you are going to be booking for now will be the remaining concrete underneath, the remaining concrete in the base underneath the oversight concrete. Because if you take everything once like this, it means that you have over measured for this part, because you measured this 2 times. So in this video, we're assuming that when we measured our oversight concrete, we minus or we less the concrete for the what base. So we're going to be taking our base now. We're going to be measuring our base now as this volume of concrete for this box here. So we know that the dimension from here to here is total 250. How do we find the dimension from here down to the top of our oversight concrete? We know that from here to here is given as what? 100. Then we can ask it, since the thickness of our oversight concrete, our German floor, is what? 150. Then we can ask say 150 plus what? 100 will give us the total length of the what? Base, and that will be what? 250. So now we know that this now is a what? Square, and the area of a square is what? Length times what? Length. So 250 times 250 will give me what? The area. So now we can now write base. So the length of the base is 0.25, 250. The width will be 0.25, and then the last parameter would now be the width of the staircase, which is from here to here. That is how wide the staircase foundation will be. It will be as wide as the width of the staircase, which in this case is 1200. So that is by what? 1.20, and then you close. So if you multiply everything that you have there, what do we have? 0.25 times 0.25 times 1.20. That will give me 0.075, approximately 0.08. So doing that, you can now describe detail, that is reinforced into concrete, to the base of staircase structure. And then you close. So now if we find for the summation of the volume of concrete for the base, the landing, the waist, and the step, the summation of everything here will give me the total volume of concrete for the what? Staircase. So let's do that now. 0.64 plus 0.57 plus what? 0.74 plus 0.08. What do we have? That will give me what? 2.03. So 2.03 is the total volume of concrete that we're going to be needing to construct the steps, waist, landing, and the base of what? The staircase.
So I will be ending the video here because the video is becoming too lengthy. I'm going to be making a separate video for measuring the formwork. Please don't forget to like, share, and subscribe to this channel because it helps the channel grow. Thank you, and we'll see you in the next video.